Innolab. Today I will introduce what we have done concerned with beam-based automated regulation code checking system development. I want to share how we developed the technology until now and what is the current issues we have. Cospec Innolab is a software development company specialized for BIM technology, especially for IFC-based technology. IFC viewer and automated 2D drawing generation from IFC, and of course we have the regulation code checking technology. Above this, we also have 2D CAD technology and BIM collaboration management technology. Actually, we have started 2012. We started developing the regulation code checking module, and in this project, apartment house layout system development project, we have used the regulation code checking technology. It was funded by Samsung Construction. This system is mainly dealing with the outside of the building regulation. So we are with the building blocks, the checking the setback ratio from road and the spacing ratio for a right to sunshine and spacing ratio between buildings. This kind of regulation codes are checked in the system. This is not the inside of the building models checking. So we have used a block model. The 2D boundaries of the building, it built the building blocks. And the system is using the block model. It is not a 3D object-based detailed BIM model. Let's see how the system works. The system imports the site information from 2D CAD drawing. It is layered classified information, and from that information, the system calculates the maximum area of building can be built. And using the site information, such as road lines and property lines, things like that, is involved, and the system provides automatic layout functions with the constraint of the regulation code and to maximize the floor area ratio. The system is automatically checking the rules and, if possible, ways from our algorithm, and also provide the manual layout also. As you see, drag and drop the building blocks to the site, and the system real-time checking the regulation code, and it shows if there is a violation, it shows the red line to the users. So users can, through the system, they can adjust the building height or moving the location of the building, they can get the best layout. It is perfectly keep the regulation code. And the system also provides construction schedules. Apartment house is very typical way of building, so the construction schedule can be automatically generated. It is quite accurate. And estimation is also based on the performed construction estimation database. Using that database, it is very accurate. And also providing the sunshine time checking, and of each unit, and the viewing simulation is also possible. The next thing is the automated parking lot design and genetic algorithm-based site level design. This is also based on the parking lot regulation code, and also the same regulation code is used. And as you see, the parking lot is automatically generated. It is dramatically reduced the designer's time. It is very efficient, and the leveling, site leveling is very, very difficult algorithm. But a lot of variables, and for example, there has to be considered the minimum excavation of rock. So we have to consider the rock's contours, and the cutting line should be minimized, and so on, a lot of variables. So we have used genetic algorithm to automatic level design. And it has been almost 8 years. The system is until now very well used, and the regulation code maybe have been changed a little, but it is not the change of the main concept of the regulation code, just small values. For example, the distance ratio or height and distance ratio, things like that. The system is until now using well in the Samsung construction. 2013, Korean government funded big beam research project has started. Fortunately, we can participate in this project. Through the project, we have developed a lot of beam-based technology. We call it K-beam research project, and the project consists of mainly 3 parts. The first part is beam modeling part, concerned with the beam-based standards and beam libraries, and for initial stage of the design phase, this part is dealing with. And the second part is analysis and permission. This part includes the quality checking. So it is the regulation of code checking and 2D drawing generation from IFC file, things like that is the consists of the part 2. And part 3 is facility management. We are participating in part 1 and 2 and developing several softwares. And one of the software is automated 2D drawing generation system from IFC. We named it K-beam generator, which is from one IFC model, it generates 2D or 2D plans and elevations and sections automatically. So it supports the regulatory process. Ideally, when designers, architects submit the e-submission documents, they just submit one beam model, and it includes all the information for 2D drawings and any kind of information included in the beam model, and also part details and even the cost information can be linked to the beam model. So we have developed this K-beam generator, and hopefully in the future, no need to submit other 2D plans and things like that, just submit 3D beam model. 2016, finally, we have beam-based automated regulation code checking system, named it K-beam SS. K-beam SS consists of 3 parts. The first part is regulation code management part, and the second, checking engine, and third is code check viewer. We have used the K-beam generator, as you see, as the viewer technology, 2D and 3D viewer technology, and for flexible way of managing the regulation code, we have separated the regulation code as code check logics and built-in functions. For example, if there is a stair clear with checking code checking logic, as you see, this is a code checking logic, Python script-based logic, and this is built-in functions. For example, this is select stairs. All the stairs in the beam model can be selected, and then the for and next is loop, and the select clear width of the stair. So using the built-in functions, users can make this kind of code checking logics. So regulation code can be not editable, but sometimes the architects or designers need their checking their own model. So they can make this kind of logics for themselves. And users who are familiar with the software engineering, this is very easy to make, but generally people do not know about the programming. So for the users, the system automatically generates the initialization value here, and if the regulation code can be sometimes changed, you can change the value here, and it can be applied directly to the code checking. And K-beam SS we have developed a lot of Korean regulation code, and fortunately, we can participate in the Singapore I-Grant automated code compliance checking project. So we have developed the system and we named it SBIM-SS. I'll show you some demonstration about the code checking software. And lower left part is showing the regulation code list. And right part of the lower part is the checking wizard. So users can double click in the checking wizard, the system showing the 2D and 3D. If there is violation, it shows what is the problem. And this is the headroom height checking function. And as you see, the system is checking all of the human accessible areas height checking. So if there is any issues, if it is lower than standard 2 meters, it checks very precisely. This is a little slightly overlapped with the slab and stair. It is very difficult human being to check this kind of errors, but the system is clearly and accurately find the violations. Next thing is stair trade width check. It is the similar way. The system is checking every stairs and checking the trade width. And sometimes it's a lot of regulation code concerned with the stairs. The risers height and the trade width should be uniform, things like that. The kind of regulation code computer is very precisely checking, and if there is errors, people can know easily. And also lots of checking examples. Maneuvering spaces at the doors have to have enough space for the door, and the vertical drop checking. If the height is higher than 1 meter, there should be some kind of safety barriers. This kind of part, the system is checking every part of the building and finds the violations. And vertical drop part, there should be safety barriers. Every object can be a safety barrier. So system is checking railing and wall, everything checking for safety barrier. And also handrail height check is possible. And clear landing check of the stair and evacuation route distance check. For every room, have to short distance to evacuation stair or evacuation exit. So the system is checking every spaces to help it is proper distance or not. Of course, we have also reporting function. So it is exported to Excel file or PDF file and BCF file. Building collaboration format, which is the standardized format of the sharing BIM information. Now, we have the technology. If there is a BIM model, well-defined BIM model, I think our team, we can do any requested regulation code checking is possible. But the issue is that to check model correctly, the model should be follow the modeling guide, such as modeling rules or mandatory objects should be built, and they should follow the naming rules and should input some properties. Important properties are missed, the system cannot check well. So, wrong model can be wrong wizard or not checked. People usually say garbage in, garbage out. I really hate that word, but even when we are developing the system, we make a lot of testing models. Even in the testing model, we miss the properties and misspell the name of the space. So the system cannot check that kind of things well. So we want to minimize this kind of things to using the technology like such as pre-checking mandatory modeling object or the naming inference property inference or using AI technology to object recognition, things like that. This is the pre-checking the space object. Usually, for every code checking, the space object is mandatory, essential, needed. So, but sometimes, some parts, space is missed like this, very small part, but it is needed to checking and balcony, things like that. So the system lets users know this part has missed the space. Usually, in case of Revit, checking the space is a little difficult. So a lot of missing spaces exist when we are testing BIM models. So we are providing the pre-checking functions. And the next, if there is a space named auditorium. Auditorium can be theater, hall, concert hall, chambers, but to precise regulation code checking, it should be classified as very accurate code. This is something. So most countries is the space classification code property input is mandatory, but it is very difficult. Architects cannot remember the code or the name, but it should be input for checking. So we have developed space classification inference functions using the space name and synonyms and typos and properties, which the system is inferencing and recommend proper classification. And users can see whether it is correct or not. If it is correct, the system get the information and go checking again. If there is a regulation code concerned with the partition wall between housing units, it was not checked because if you see, this is a space classification module. Sorry. Yes, as you see, this is unit A, unit B. It has to be classified as a classification code, but the classification code property missed. So if you run our inference checking function, running inference, and system checks this could be unit. And if the user gets the information well and checking the partition between words, it answers correctly. These kind of things are needed and we are developing. The next one is this is BIM model. Usually BIM model have a lot of objects. It is well organized and classified well. But sometimes there is unclassified object, a lot, mass object we call it. In IFC, it is building proxy element. And this looks like stair, this looks like escalator or door, windows, but it is mass. So when checking the regulation code, the system cannot recognize this is stair or windows, doors. So the regulation code concerned with this type of the object cannot be checked well. So we have applied the AI technology, object recognition technology, and reclassify it to the well-classified object. For example, this is running. The system is checking every proxy element object in this BIM model. And checking, this proxy element could be door, confidence 99%. This could be wall, 98%. If the user can see, like clicking and see the result, this could be door, and system recommend this could be door, and also could be door, things like that. So if you have a missed something you haven't classified the object where the system can assist you to where classified BIM model. So now we want to be the kind of information input or mandatory object. That things can be a big burden to architects or designers or modelers. So we want to reduce the burden down through smarter inference and more smart inference and interactive interfaces. Through this technology, we want to remove the burdens to the architects or designers. We are now focusing on this. Thank you.